Hello everyone. I wanted to work this problem from the tail section of 1.6. It's one of the harder ones in the problem set. And the assumption I'm making here is that you've worked your way through the problem set and you're getting proficient with the easier ones. And you might want to see a more difficult one. And in addition to that, there's going to be one of this caliber on the midterm, as well as a few easier ones. So I'm going to work this one. If you want to stop the video here and work it yourself, go ahead. First thing I want to do though is do a quick survey of what's called the laws of exponents. Now the textbook is not currently calling 1, 2, and 3 here the laws of exponents. By the time we get to page 440, Bittinger and Ellenbogen will call them the laws of exponents. And indeed, in math education, if you were to do a Google search on the laws of exponents, these things would all pop up. This is the standard term, and these are the 3 standard laws. And the first one here is when the bases are the same and you're multiplying, you end up adding the exponents. The second one is when you're dividing and the bases are the same, you end up subtracting the exponents. I want to reinforce that with a little mnemonic here, a mnemonic device. Namely, the division bar looks like a minus sign. And so what's going to happen here is you're going to have 3 minus 2. And this is a critical idea here, these circles here, because when you have negative exponents, what happens is you generate a double negative. And I see a lot of people falling down on this particular law. Fortunately, the problem I'm going to work gets at this very instance. Now, the third law is when you have powers of powers and you multiply. This fourth thing down here isn't a law of exponents, but rather it is one of the core ideas in section 1.6, namely how to convert negative exponents to positive exponents. And let's just go over that really quickly here. You can change the exponent from a positive to a negative or negative to a positive by moving the base and the exponent from one story to another story in a fraction. So for instance, the y goes from the bottom story to the top story in a fraction here, and the negative 2 gets toggled to positive 2. Notice the y itself doesn't change in sign or value. And I'm going to do this one here on the fly. I'm going to take it from the top story to the bottom story. Notice that the base itself does not change. Rather, the exponent toggles in value, goes from a minus 2 to a plus 2.
Alo.